Hi everyone, I'm Xuewei Wang from Meta. Today I will introduce our work on towards the better ranking consistency, a multitask learning framework for early stage ads ranking. First, I will introduce some background for the ads ranking system. There are two common settings for the modern ads ranking system. The first one is a multi-stage ads ranking, and the motivation is to have a better trade-off between the capacity and efficiency. For instance, for the early stage ads ranking, given the hard latency constraint and the relatively large ads candidate, we can only use a simplified model to achieve better efficiency. And for the final stage, we can utilize the large capacity models to achieve a higher accuracy. Another common setting is multi-objective ranking. After we have the top ads selected from the final stage ranking, we will pass them into the ad auction process. And the ad auction will decide which ads will be shown to the user. The order of the auction depends on the total value of an ad. And in Meta, there are three major components for the total value definition. The first one is the bid placed by advertiser, and the second one is estimated action rates, such as CTR and CVR prediction from the ads ranking model. And the third one is ad quality for users' ads experience. In our framework, we mainly focus on optimizing the later two components of the total value. Then I will introduce our motivation for improving the ads ranking consistency. So the ideal status for ranking consistency is that the early stage and final stage ads ranking can have the same ranking orders for ads candidates. In real situation, we are facing with the ranking inconsistency that the top ads in the final stage are actually ranked low in the early stage. The root cause of this ranking inconsistency is from the gaps between the final stage and early stage ads ranking. For instance, there are performance gap between the final stage and early stage. And also, we are suffer from the total value definition inconsistency as the early stage ads models development lags behind the final stage models. And also, we have the selection bias for the early stage ads ranking models. The early stage ads ranking models are mostly trained on the impression data, but during the inference, the early stage model need to infer on both non-impression ads and impression ads. In order to have a better measurement of the ranking consistency, we propose to use ads recall to measure the ranking consistency. The reason we use recall is that we only care about the top ads candidate for user impression rather than the lower ranked ones. However, we are also facing with a challenge because calculating the accurate recall is difficult given the large candidates. Our solution is to leveraging the online simulator to relax timeouts between stages. And the outcome is that we can make sure all of the ads in the full ad request can be ranked in the simulator using the final stage ads ranking models. And finally, we will log them in the replay log to calculate the offline simulated recall. The top K in the simulator will be the golden set of the ranking candidates to calculate the recall value. Then I will discuss on our proposed methods. There are three major benefits for our multitask learning framework of early stage ranking. The first one is that we can achieve better ranking consistency by learning from the final stage as quality models or CTR model. The second one is that we can achieve significant resource saving by model consolidation. And lastly, we have some method to mitigate the selection bias by using the augmented data from the non-impression ads. Here is our detailed components of the framework. First, we develop the CQS task for the quality as quality. And the consolidated quality score is the final stage total quality score. This is the input of the ad quality as a transformation to compute the as quality in the ad auction process. And the CQS, as you can see in the equation, there is just the sum up of the final stage quality event score. And we can just develop the CQS task arc in the early stage to learn the CQS label with regression loss. The benefit is that we do not need to predict each component of the quality at quality in the early stage. In addition to that, we also have the final stage CTR distillation to learn from the final stage eCTR information instead of just learn hard 0 or 1 binary labels. And the final component is the data augmentation, since we're adding the non-impression as with a final stage eCTR as a pseudo label for the CTR task. And it can also help debias both at quality and also CTR task. We also conduct several experiments to justify the benefit of our framework. First, we consolidate as quality models and build individual CQS models to justify the benefit of the CQS optimization goal. Here are metrics we used in the experiments. For offline, we have the soft recall as discussed in the previous slide. And also we use the total value as the major online metrics to justify the business potential of our ads. And also we list some ad quality metrics since we are changing the as quality models. And as you can see from the table on the right side, we achieved improvement on recall and total value. And also the ads quality becomes better, and the CTR also lift. It also implies the better ads quality can also lead to higher CTR, and it's just the benefit of adding the ads quality models in the ranking component. Also, we conduct multitask learning of CQS and CTR task. As you can see from the table, we observe significant recall improvement and also total value improvement. And the CTR and CVR also increased with better ads quality achieved. As you can see, the X out reduced much more compared with just consolidating ads quality together, which shows the multitask learning of CQS and CTR can actually benefit both CTR task and also quality task. Finally, we conduct the ablation study for each components. We build the dedicated CTR models and also CQS models and the multitask framework without teacher or without augmented data. In our experiments, we do see that the augmented data plays a critical role in improving both recall and also total value for online performance. And the dedicated CTR plus CQS will lead to larger total value divergence and also heavy infra cost increase. Here are our conclusions for the experiments. Each component in our multitask learning framework is essential to improve the performance from both recall and also online performance. And our framework can be generalized to other use cases, since the CQS can be applied to any ads ranking system with ads quality components. Also, compared with NE and also MSE metrics, the offline recall evaluation can reflect the online performance better. Therefore, we want to emphasize that the single offline metrics for an individual ads ranking model may not be reliable to reflect the model online performance. That's all. Thank you for listening.